Medians of a triangle. See, we know that opposite side of a vertex, is it or not? Like for all the line segment, we have the midpoint. Consider the triangle ABC and let D be the midpoint of BC. D be the midpoint of BC. Then a line which connects the vertex A to the midpoint of the side opposite to the vertex A. Which side is opposite to vertex A? This BC. Line which connects the midpoint of the line which connects the vertex with the midpoint of the opposite side. Midpoint of its opposite side is called as median of this triangle. Likewise, how many medians we have? How many opposite sides we have? That many medians we may have. Like for this vertex A, I connected with the opposite sides midpoint. The same I can do for B as well, right? Say that is E is the midpoint of the side AC, which connects these two, also a median. Are you saying 2 medians? 3. For C also we can draw another median, like we'll take this as F. So there are 3 medians can be drawn. Likewise, whether all medians are lie in the interior, yes, all medians lie in the interior of the triangle. Okay. Next, altitude. Altitude means height of the triangle. Like that makes 90 degree. The line which connects a vertex with its opposite side and makes 90 degree is called as altitude. There is a huge difference between median and altitude. See, as per the diagram, it may looks like both are same, but consider a triangle like this. This like one triangle you consider. In that, obviously midpoint will be somewhere here. Is it or not? I'll name this as PQR. So the line which connects the opposite midpoint is called as median. It is not like perpendicular. It may or may not be perpendicular, the median. Then what you will say as altitude for this triangle? This is the altitude, which is perpendicular. So that arises a question that medians and altitudes are same line? Need not to be. We can't say no. Need not to be the same line. It may be same line also. Okay. Then in which case both will be same? In the case of equilateral triangle. In the case of equilateral triangle, when I draw 1 1 dash in each all sides means those all 3 sides are equal. So if equilateral triangle is there, the median as well as the altitude both will be same. The same applies for isosceles as well. If these two sides are equal, then The midpoint connected as well as the height perpendicular, both will be same. Apart from this, the median is different, altitude is different. Now, how many altitudes can you draw for one triangle? So you are asking me only 1 or 3. I am asking you how many? 3 altitudes can be drawn. Okay? And that arises another question. When you draw 3 altitudes, all the 3 altitudes are equal, shall we say? Need not to be. As per this diagram, if you refer, means it may looks like those are equal and we can say all the 3 altitudes are equal, but it is not work like that. Take this one. For this one, altitude is here, and for this one, altitude is here. Does it looks like same length to you? So altitudes are need not to be of same length. What about in the case of equilateral triangle? In the equilateral triangle, it will be equal. Also, isosceles triangle, will it be equal? Why you are saying no? Only 2 sides are equal. The altitude need not to be equal. Okay, clear? Okay. So you understood what is median, what is altitude. Now, the other point, all the altitudes will lie in the interior of the triangle or not? Okay, you are saying yes. We'll check whether all the altitudes will lie interior of the triangle or not. I am taking one obtuse angle triangle I am taking. Is this obtuse angle triangle? As you said, from this vertex, if you are connecting to the opposite, yes, it is altitude. And from this vertex, we are connecting to the opposite. Where it will come? Obviously, it will not come inside. We can extend this line, and for this line, this may be perpendicular. Or else I'll see from the, I'll demonstrate from here. See, from this vertex, the perpendicular distance is inside or outside? Outside. So, we can conclude that altitudes, not all the altitudes are interior. Like you can say, need not to be. If that is an obtuse angle triangle, the altitudes will lie outside as well. Okay, that is it. Then that takes us to the this think and discuss we done, I think. See how many altitudes can a triangle can have? 3. Draw rough sketches of altitudes BC and from the following figure for acute angle, right angle, obtuse angle. For that obtuse angle, I demonstrated here. Okay. Will an altitude always lie in the interior of a triangle? No. Now only we discussed. Can you think of a triangle in which 2 altitudes of a triangle are of its 2 sides? Altitude itself, the side of a triangle. Yes. Think of a right angled triangle. From this vertex, which one is perpendicular distance? Okay, so this acts as side as well as the altitude. One altitude. Likewise, from here, It acts at side as well as it is. Are you noting all this down? Doesn't seem like you are noting this down. Take your pencil, near to that in your book itself you mark it. Right angled triangle. This obtuse angle and all I drawn one altitude outside, right? That also you can draw. Use pencil, girl. You are using pen. That will hurt the book. Okay, the next question. Can the altitude and median be same for a triangle? The answer is need not to be. That is it. The exercise 6.1. One diagram is given. And D is the midpoint of this side. What is PM they are asking? What is PM? PM is altitude. Write altitude on the dash. What is PD then? Median. And the next question, is QM is equal to MR? QM is equal to MR? Obviously no. Then I'll ask you another question. Is that QD equals DR? Because this is midpoint. This is not a midpoint. Okay. Draw rough sketches for the following. A, B, C, B, E as median. Median means how you will draw. Either way you will draw. It should not be like only like this diagram you should draw. You can take anything. See, I'll take D here. This like you can draw. B. So B, E as median, then A, B, C. Okay. The other way also you can go. I told you, right? Anti-clockwise name it. Then this like you can draw only. And next, PQ and PR as altitudes of the triangle. Simply name this PQR. That is all. Oh, sorry. PQ and Yes, that is what I also addressed. Anti-clockwise also you can draw. B, C, then this line will come like this, I said. They told you or not? I told you. So here, a triangle PQR in which PQ and PR are altitudes of a triangle. PQ and PR are altitudes of a triangle. Is that possible? Two altitudes. See, PQ is only altitudes. The triangle name itself PQR. Only one is possible. So it's not possible the other way. Any other way you think of? No. Next, XYZ in that YL is an altitude in the exterior of the triangle. Altitude in the exterior, YL. So, XYZ. Either way we will name it because they asked YL is the altitude in the exterior. Next, verify by drawing a diagram if median and altitude of an isosceles triangle can be seen. Yes, they are same. Okay, we verified already, right? Okay. Next, exterior angle property.